Now that we've defined what it is for a function to be continuous at a point, I wanted to talk about the different types of discontinuities that there are, and then talk about which one of the parts of the definition of continuity are being violated. So the first one, and this one tends to happen kind of frequently when you talk about piecewise defined functions, but this kind of discontinuity happens when the left-hand limit and the right-hand limit are not necessarily equal to each other. So if we take the limit as x approaches a from the left-hand side of f of x, and it's not equal to the limit as x approaches a from the right-hand side of f of x, you get what is known as a jump discontinuity. Discontinuity. There we go. So the only way that a jump discontinuity exists is if the left-hand limit and right-hand limit both exist and are not equal to each other. What we're saying is that the y value jumps from one value to another before continuing along its way. Second possibility happens when there is a hole in your graph and the left-hand limit and right-hand limit are equal to each other, but the value of the function is either not defined or it's not equal to what y value you have at the hole. So this is one where the limit as x approaches a of f of x exists, and either f of a is undefined or f of a is not equal to the limit that we mentioned right back here. So either it's undefined or it's not equal to the value of the limit. This one has two different names. The sort of easy name for it is the hole discontinuity. The other name that it has is it's called a removable discontinuity. Removable means that we could make this function continuous by changing exactly one point. And if we were to change that open circle to a closed circle, the function would now be continuous at that point. The third possibility is you have a discontinuity anytime you have a vertical asymptote. Now, vertical asymptote implies one of six things. The one-sided limit is either equal to positive or negative infinity, that's coming from the left or the right, or the two-sided limit is equal to one of those two things. So, in this case, this comes from an infinite limit. And so we call it an infinite discontinuity. Usually happens with rational functions. Those tend to get a lot of vertical asymptotes. We also see them on functions like the tangent function, cotangent function, secant function, and cosecant function. So the thing that would not be true here is basically the same thing as number 2. Except that it's possible that, well, why don't we just say a 1 or 2-sided limit is infinite. So that's what will happen for an infinite discontinuity.